Okay, going to do a little bit of work now on the moving coil loudspeaker as the application for the stuff on magnetic fields. Just going to go through this PowerPoint. So just having a look at a couple of diagrams here to try and show you what's one of the main features of it. And this one here, you see here, here's the magnet is actually all of this in here. Okay, and so you've got in here what we call the voice coil. That's the magnetic the magnetic coil. They call it the voice coil because that's where the voice signal goes onto it. So that's you've already got an incoming audio signal that's now being processed, and it goes into that. And you've got two sections of the magnet, and this in cross section, you see that may be, I think it's probably the north here and here, and this is the south in here. So therefore you see you've actually got a magnetic field moving in this direction here. These suspension spiders, that just helps keep the cone in the right position, in a proper sort of mean position when there's no signal. And this is the actual cone in here itself, which actually does the vibrating. Here it's a little bit, you can see it's a little bit harder to pick up what's going on here. Might go to the next one to see the diagram here. I was just going to talk about the cone. Okay, so the cone is made to vibrate backwards and forwards, and this produces the sound wave. That's pretty obvious what's going on. So basically the cone, its whole self, is moving in this direction here all the time. As the force, remember the force will be at right angles. So if the field's this way, the force to move this coil, and this whole coil will move, will be in this direction here, going sort of left to right there. Okay, and the field going from top to bottom there. Okay, the magnetic structure, this just gives you a bit of idea. Okay, so it is a north pole here, a south pole here, a north pole here. So you're basically getting a uniform. So it is a bit better view of it in cross section. Of course, if you've got a north pole, you've got to have a south pole down here. So it's in this section just there where you've actually got a uniform field. Down here, you've got two south poles next to each other, so the field's going to be quite different. So it's just in this little section here where you can see the cursor is where we have this uniform radial magnetic field, and you see how the shape of this magnet, making it circular, is how you make sure the field lines are perpendicular to the current. The current is sort of wound around, the coil is wound around this center piece of the magnet. Okay, magnetic structure is designed to produce a radial magnetic field across a small circular gap. So this is the gap we're talking about here. Okay, going on to the next bit. So the voice coil. The voice coil is a coil of wire which is attached to the cone. So it's connected to the cone. The magnet isn't in the same way. The voice coil sits in the gap in the magnet structure such that the wire is always perpendicular to the magnetic field. So it's always sitting in there in this little gap there. You can see there's the little wires of the coil sitting there. You can see the current flowing down this way. But if you look here, you'll see the current direction is either out of the screen or into the screen, which is going to be at right angles to the field. Okay, the action of the loudspeaker. When a current passes through the voice coil, there will be a force on the coil. The reason being because it's a current will set up a magnetic field. Okay, and that magnetic field is going to interact with the magnetic field of the pole of the permanent magnet, which is the blue, and that's going to move. The permanent magnet, the blue one, is fixed. So That's not going to move anywhere, so it's the other one that's going to move. It's the voice coil that's going to move. Okay, this force will be perpendicular to both the wire and the magnetic field. So basically, it's coming here. There's a compression as the voice coil gets pushed this way, and when the voice coil gets pushed back this way, you'll get a rarefaction going on. Okay, the cone will either be pushed away from the magnet or drawn towards it, depending on the direction of the current. Okay, once again, if an AC current is passed through the voice coil, it will cause the cone to vibrate backwards and forwards. Okay, so I think we might have a bit of an animation here, no? The movement of the cone will produce compressions and rarefactions in the air in front of it. So it says in here. So, there you go, nice little animation there. So you see, as it's moving forward, so this would be the case of a signal, just a constant frequency signal, not a complex voice signal. But a complex voice signal is actually made up of lots and lots of different frequency signals of different amplitudes and phases. But the basic principle is this, and you can see how that pattern of rarefaction and compression is what is moving down and down in this direction, in the direction of propagation. And there, just last of all, is the YouTube clip. If you want to take that URL, you can't click on that, unfortunately, it doesn't get you there. But if you can have a look, there's another YouTube on how they actually make the things rather than just how they work. Okay, so I hope that's given you some bit better understanding of how the loudspeaker works.